Alrighty, hello everyone. Welcome to this interactive stargazing on this really nice September night, and welcome to Lowell Observatory thereafter. My name is Claire. I am a public program educator here at Lowell Observatory. So basically, what I get to do tonight is talk to you guys about all the cool images we're going to be seeing and kind of facilitate this interactive stargazing. So if this is your first time joining us, basically what we're doing is we're up at our Geo Valley Open Deck Observatory using our plane wave telescope, which has a Malin cam attached to it. So we're creating a live feed of the images that we're taking for you guys and projecting it onto your screen. So basically, if you have any objects that you would like to look at, just type it into the YouTube chat and we'll be able to put in your requests, and we can find those objects in the sky and get a really nice image for you guys, and we can kind of just have this really awesome discussion about what we see in the night sky. So kind of to start off, I have one that we're going to start off with, and then we can move into some of your options. I'm going to start off with the Swan Nebula. So this one is located in one of these star fields of Sagittarius. So we're pulling that up right now. What you see in front of your screen is our plane wave software. This is just the software that we use to control our telescope. It's pretty cool. It's kind of just like a point and click type thing. So we're moving it and the telescope is moving it thereafter. And pretty soon we'll get a pretty nice image. It's kind of what you see here in this screen, kind of what you saw before, those like streaks of stars. That's because we didn't stop the image. So it was still taking an image and gathering that light as it was moving, which is kind of what creates that effect. But here is the pretty amazing Swan Nebula. It's also known as M17 or the Omega Nebula. It goes by all of these names. It's about 5,000 light years away or so. Again, it's in the constellation Sagittarius, and it is one of the brightest and most massive star-forming regions in our galaxy. So kind of what you see here, and kind of why it's called the Swan Nebula, is the orientation is slightly upside down right now, but it looks rather like a swan. And this is just a big giant ball of hydrogen gas that will eventually create tiny little baby stars in the night sky. So this is where stars are formed, in these types of gas clouds. We call these stellar nursery nebulas. And this is one of the biggest ones that we have in these types of star forming regions right here. So that one's a pretty good one to start off with, but it looks like we already have some requests, which is pretty awesome. So we have one from Eugene Stempel. Can we stop at Pluto? So we can, but the thing is that Pluto is so incredibly small that it'll look quite a lot like the stars around it. But that's totally okay, because we can actually pull up the live feed, and then we can pull up some of the older images that we took with Pluto and kind of show you how we can tell which one is Pluto when it looks exactly like the stars in the sky. So this is actually pretty cool, a great one to look at. Thanks for this request, because it's perfect for Lowell Observatory. Lowell Observatory discovered Pluto back in 1929. So this is the home of Pluto, and kind of what we're going to show you is how we discovered Pluto. So the screen before you, you can't really tell which one is Pluto. Again, looks just like any background star in the sky, and it's really super tiny and faint. So when we try to think about this, well, how do we find a super tiny and faint object in the night sky? Usually what we have to do is take pictures and compare them. So that's what we did. Here's some of the pictures that we took with this camera that we're using right now, and we took them across 2 different nights. So if we blink back and forth, and if you kind of look at the center of the screen, you'll be able to see an object that's moving. And again, looks just like a star. So this is the process that Clyde Tombaugh, the person who discovered Pluto, went through all the way back in 1929. So he just flipped between these 2 images, found the movement between them, and that's how we actually discovered the planet. So again, with just this image right here, we can't really tell which one it is, but you can tell when we do the blinking back and forth. So that's a pretty awesome request. And you guys got to see Pluto, which is pretty cool. Looks like we have another one. So we're sticking with planets for right now, and we are going to go to Saturn. So the thing about this telescope is that it's really good for some more deep space object stuff. But what we're doing now is basically we're turning down the sensitivity for our camera because Saturn is super, super bright. And so we need to turn down our sensitivity quite a bit to try and resolve some of that detail. But we'll be able to get, those are the rings of Saturn. Nice, that actually looks awesome. So you can see, you can even start to see a little bit of the Cassini divide, that black band right in the center of those rings. So this is Saturn. Saturn's my favorite planet personally. It's one of the greatest planets to look at if you have a telescope or a pair of binoculars. But yeah, it looks like we got the rings of Saturn for you. So that's a pretty cool one. Fun fact about Saturn is that it is so incredibly not dense, I guess you could say, that it can actually float on water. So it's a gas giant planet, and its rings are made out of tiny ice particles that are that range in sizes of like a grain of sand to about the size of a car or even bigger. So it's just all these tiny ice particles creating the rings of Saturn, which is pretty cool. But we have another request, and this time we're going to go from one of the smallest objects in the solar system to one of the biggest things we can have in the entire universe. So if we can grab the Andromeda galaxy, or M31, we'll head over there. We're finally getting into the time of year when we can start to see Andromeda and some of those galaxies on that side of the night sky, which is pretty exciting. Now, a little bit about the Andromeda galaxy. Hopefully it will be up enough for us. I think we're just searching for it right now. But a little bit about the Andromeda is that it's about 2.5 million light years away, which may sound like a long distance, but it's actually the closest galaxy to our own Milky Way. So that's pretty cool. And another cool thing is in about 4.5 or so billion years, the Andromeda galaxy will combine with our own to create one big galaxy that is going to be called Milkdromeda, maybe something like that. Definitely a weird candy bar combination nonetheless. But here we go. Nice. So because the Andromeda is so close to us, it's going to be incredibly bright. You can actually see the Andromeda galaxy with your naked eyes in the night sky if you're in a nice clear place with not too much light pollution. So basically what you're seeing in the screen in front of you is, there we go. So we have a nice bright galactic center that's kind of like that big fuzzy ball that you see in the center. There's just so much light coming out of that area, and that's kind of what we see here. But if you look just below that, you'll be able to see some of these like dark, shadowy, wispy spiderweb type stuff. And those are actually the dust lanes of this spiral galaxy. So Andromeda is a barred spiral galaxy, and we're starting to see some of that dust structure going around that center of the galaxy, which is pretty cool. Andromeda galaxy is a pretty massive galaxy. It holds about 1 trillion solar masses, so it's quite a big galaxy. And again, it's going to head towards us in about 4.5 billion years or so. So we got quite a lot of time, but it'll be definitely an interesting sight to see if things work out that way. So I'm going to keep going on with my list while you guys think of things that we can look at. Let's go ahead and head to the Trifit Nebula. So we're kind of heading back to the area of where the Swan Nebula was. So we're basically looking towards the center of the Milky Way galaxy. We're actually seeing some of in that arm of the Milky Way galaxy. Now the Trifid Nebula, or M20, is a pretty good one. We're starting to pull up that image in a sec. There we go, we're starting to get it. You can start to see some of that pink and blue coming in. We'll wait for another cycle for the image to resolve. There we go, nice. That's a great image of the Trifid Nebula. So the reason why we have this name Trifid is because Trifid means divided into 3 lobes. So that becomes rather apparent while you look at this. So there's actually a combination of different types of nebulas within this one bigger nebula. So the red part that you can see, the one in the center that's nice and pink, that's going to be an emission nebula. The blue part is going to be more of a reflection nebula. In those dark like lanes of gas that's mostly separating in that red part is going to be a dark nebula. So that's kind of what creates this segmented shape of this nebula, which is pretty cool. I really just love the colors out of this one. This is just an amazing one to look at because it has so many different structures in it. And again, it has those basically 3 different types of nebulas all in one, which is pretty cool. Trifit is also about 4,000 light years away or so it's fairly close to us. And it's a star-forming region in one of the arms of our galaxy. So it looks like we have another request keeping with the nebula theme from John Alder. So we're looking at the Eagle Nebula, home of the Pillars of Creation. That is totally correct. This is probably my favorite nebula to look at. Whenever I'm out doing the plane waves or taking images, I always love to stop by the Eagle Nebula. It's pretty amazing. So the Eagle Nebula, similar to the Swan, is going to be a star-forming region. There we go. So we're starting to get it nice and clear. We'll just, another cycle of image will get some of those streaks out of the way. We can already see those pillars right in the center. So you can see this nice like rosy colored gas that's glowing quite bright. And in the center, you'll see these like dark pillars of gas. So we call these the Pillars of Creation. And that's because this is a giant ball of hydrogen gas that is also creating stars. And stars are probably one of the most important things in the universe because they create all the elements that are possible for life in literally everything around us. So stars are pretty important. And of course, before that, these star-forming regions are obviously important too. But the Pillars of Creation and the Eagle Nebula itself is one of the most famous Hubble images that have been taken. So I bet if you just searched famous Hubble images, this one would definitely come up. It is extremely famous, and the Pillars of Creation in general is just such an important area in the night sky for stellar evolution and astronomy as a whole. So that was a great one to look at, a great option. So I guess still keeping with the nebula theme, but kind of diverging a little bit, we're going to look at a new one that we found here at Lowell Observatory called the Bug Nebula. So this one is a planetary nebula. It's quite a bit different from some of these star-forming region ones that we have been looking at. So planetary nebula is going to be at the opposite end of a star's lifetime. So planetary nebulas are showing us the death of stars, and mostly the death of stars that are about the size of our sun. So planetary nebulas are not supernova remnants. They're quite different. So we're starting to get this one in. So it's a tiny little nebula, but if we can get it, we'll be able to kind of see this like shape of a bug with like antennas coming off of it. But again, this one is showcasing the end of the life of a star. So basically how these form, it's pretty cool. A star, as it's nearing the end of its life, becoming a red giant star, will start to shed gas off and kind of just like push all of these layers of gas out, and it creates this nice like round planetary shape, and eventually it'll move off into these different types of shapes as well. So that's basically how these form, is just a star that is turning really old, nearing the end of its life, just pushing gas out, ionizing that gas so it's nice and glowing, and that's what we see in the night sky. So kind of going off that, I'm going to show you another really cool planetary nebula. We're going to head to the Dumbbell Nebula. So that one is also one of my favorites to look at. The Dumbbell Nebula is known as M27. It's actually sometimes called the Apple Core Nebula too, which might become a little more apparent once we get to that image. But it was actually, the Dumbbell Nebula was the first nebula to be discovered by Charles Messier. So when we say things like M27 or M31 or M11, that might seem kind of weird, but basically what we're referring to is this massive catalog that one of the astronomers back in his time, Charles Messier, created when he was actually trying to look for a comet. So he was searching the night sky. He didn't find the comet exactly right away. He was searching and searching, but all these other really cool objects and put them into a catalog. And so that's kind of what we do when we refer to these M objects, is we're referring to that catalog. So here is the Dumbbell Nebula. It does kind of look like an apple core. I really like that. But this one, again, planetary nebula too. So I really like this one because it showcases the colors really, really nice. So in the center, we see this nice blue/turquoise color. On the outer edges, we can start to see some of that nice red, rosy color, maybe even a little bit of orange. Now, colors in gas in specific is really cool to astronomers. So this is spectroscopy. So we can actually tell what a star is made out of and what this gas is made out of, what type of elements this gas is, simply by looking at what color it is. So that nice red color is going to be mostly hydrogen and helium, and that blue color is going to be towards the carbon and type of stuff. But we can tell kind of what a star went through during its lifetime by looking at the colors of gas that it emits with these planetary nebulas or supernova remnants as well. So let's see. We have another request. We'll go to Albireo. This one is a fun object to look at. So Albireo is a binary star system, we think. So a binary star system is basically two stars that are like I like to kind of say they're in an internal best friend like relationship, because they stick together basically until one of the stars dies, basically. So they're locked together in this nice little orbit around each other. But Albireo is really cool is because there's two different colored stars, which means that these two stars are of different ages. So that blue star you see up to the right side of your screen will be young and really, really hot. But the red star is going to be a little bit old and a little bit more cold. So these are two different ages, two different temperatures for sure, which it's a great way to showcase just these different types of colors of stars. So yes, stars do have colors, and they're very important for us to understand how old they are, how hot they are, and different stuff like that. But keep your requests coming in. I'm going to show you guys another really cool planetary nebula that's in the same amount-ish of sky as Dumbbell. We're going to go to the Ring Nebula. So this one's cool. I really love this one. So when we think of planetary nebulas, you might be wondering why we call them planetary when they really have nothing to do with planets at all. Back when astronomers were first discovering these types of objects, and they didn't have as good as telescopes as we do now, if you can imagine when they were looking up, it probably looked like a really fuzzy Jupiter or something like that. And so that's kind of how the name came about, is some astronomers explained these types of things as a planet which is fading, which you can imagine probably made a lot of sense just based off of what they had to look at with. But here's the ring. Again, you can see those really awesome colors. This one's in even more of a circular shape. And the Ring Nebula is about 1.3 light years in diameter, so it's a pretty big object in the night sky. But the really cool one about this one is that we can see the white dwarf star at the center of this nebula. So the white dwarf star is actually what is allowing us to see the gas. It is ionizing this gas, making it glow nice and bright. But the white dwarf star, that star right in the center, is going to be the dead core of a star after it has shed off most of its gas. So this is basically the last remnant of a red giant star ending its life, is that white dwarf star. It kind of sit there for a really long time, and this gas will eventually dissipate, but right now it's super pretty for us to see. So the ring is always a great one to stop by. So we have another request. We'll do a planet for someone's birthday. So we haven't looked at Jupiter yet, so let's go ahead and head over there. So similar with Saturn, we'll have to reduce our sensitivity of the camera that we're using because it's going to be such a bright object, but we'll be able to get some cool resolution with this as well. So we're going to keep going down, changing our sensitivity a little bit more. Again, Jupiter is super, super bright, the biggest planet in the solar system. There we go. That's pretty good. We can start to see those stripes on Jupiter. I like to call them the bacon strips of Jupiter because they do look like bacon strips. They're the same color, but they're not actually bacon strips. They're caused by different bands of gas moving in different directions. So there's different wind speeds moving around on Jupiter. Jupiter's surface is basically just like one roiling mess of gas. So we have that big storm, Jupiter's red spot, but all these other stripes are caused by all of these different gases moving in different directions and at different speeds as well. So that's a pretty cool thing to see. Jupiter, again, biggest planet in the solar system, and it's mostly made out of hydrogen and helium gas. So for this camera, again, it's more sensitive to fainter stuff. So with some of these bright objects, it takes a little bit of working to get it into some nice detail, but that looks pretty great for tonight. You can see those stripes really, really well, which is pretty fun. I know we had a request for Bernard's Loop, but it is not up. It is in Orion, which is more of a winter constellation. So it won't be quite risen for us at the moment. But there's another type of nebula that we haven't talked about tonight, and hopefully we can get it in a sec. Oh, looks like we actually have another request. We'll check to see if the Medusa Nebula is available for us. We'll see if that works. I'm not sure if it has a Messier catalog number or not. While we check into that, Medusa is in Gemini, so that is also a winter constellation. So unfortunately, that is not up for us yet either. Hopefully, we'll still be doing this in the winter when it's nice and cold. So if you tune back in, we may be able to get that in the winter, but right now, we're not quite at the right season for that. So let's go ahead and hop on over to the Veil Nebula, if we can see anything. So the Veil Nebula is different from a star-forming region, and it's also different from a planetary nebula. So it's completely different than the ones we've been looking at now. The Veil Nebula is in Cygnus, and it's a supernova remnant nebula. So it is at the end of a star's lifetime, but this time it's a little more exciting. So before the planetary nebulas, it was kind of like this gentle blowing off of the gas. But with the supernova remnant, it is a massive star, many times the mass of our sun, that will just literally explode and push all of its gas and energy out into the night sky. So we're starting to get this image. You can start to see it kind of going down across diagonally of your screen. It's pretty faint, but we'll be able to get it in a little bit more. So this nebula is going to be really spider-webby. It's not super compact or anything. That looks pretty awesome. So we can start to see some of those colors in that gas structure a little bit more. So you can see how far this supernova remnant stretches across the screen for us, which is pretty amazing to look at. But the source star of the supernova, we can actually find this out by looking at the nebula itself, was a star about 20 times the mass of our sun, and it exploded between around 10,000 to 20,000 light years ago, or 20,000 years ago, not light years, which is fairly recent. And so we can start to see the gas coming off of that as well. And this object was discovered by William Herschel. So yeah, taking in a little bit more of a closer look, we can start to see that really nice gas structure. It's very filamentary, and it's caused by a star just exploding. This is one of the most pretty nebulas, I think, to look at, and it tells an amazing story of what stars go through when they go supernova and kind of what is left over afterwards. So if you can imagine the amount of energy that is needed to just throw this gas light years across the sky, that is what needs to happen with a supernova. It is pretty awesome to look at. So we have another request for M55, which is a globular cluster. So we're going to go ahead and head to that. Oh, that looks awesome. Nice. Yes. So globular clusters are also one of my favorite things to look at. I think they never disappoint because they're so incredibly bright and always interesting to look at. So we're going to go ahead and head to that one, and we'll see how it looks. So globular clusters are these massive clusters of stars that are kind of in a circular shape. So they're different than open star clusters in the sense that globular clusters are gravitationally bound to each other. So all these thousands of stars are going to be one big happy family for basically as long as these stars live. So they're gravitationally bound, they can't really leave this globular cluster. And the cool thing about globular clusters in general is that they're kind of interesting to us as astronomers. So these stars are really, really old, and the fact that they're gravitationally bound to each other is also interesting. So for many of the globular clusters that we observe in the night sky, astronomers actually think that they're the remnants of the cores of galaxy that our Milky Way galaxy has like eaten or cannibalized through galactic cannibalism over time. So in the early universe, and still this is happening today, galaxies will combine together. Their gravity will interact and they'll eventually merge together. So big galaxies like the Milky Way and the Andromeda can start to incorporate these smaller dwarf galaxies into them. And what we think is that some of these globular clusters are the cores of those galaxies that are left over, and everything else has kind of just been incorporated. So that's what we think about globular clusters. There's a lot of them, which is really cool to look at, but they're so incredibly bright. As you can see before you, there's just thousands and thousands of stars. Sometimes globular clusters can have 500,000 stars in them, which is an incredible amount of stars in such a small space in the night sky, which is pretty awesome to look at. So that one is a great one to look at. Let's go ahead and head to another globular cluster just for fun. Let's go to M15. So M15 is in the constellation, we're just off the constellation Pegasus, and this is another really fun one to look at. But the interesting thing about M15 is that we think there is a black hole at the center of this globular cluster, which kind of solidifies that theory that globular clusters are the remnants of cores of galaxies. Because almost every galaxy, or literally every galaxy in the night sky, has a central black hole to it. So that's kind of interesting to observe with this globular cluster. M15 is about 33,000 light years away, so it's fairly close. But as you can see, this one is incredibly bright. And this one has about 500,000 stars in it, so this is one of the biggest globular clusters that we have. This is also one of the most densely packed globular clusters as well. So with the one before, we were able to resolve the stars in the center a tiny bit more, but with this one, when we were looking at it, just the center is so incredibly bright and there's just so many stars in that region, it's incredibly packed. So that one's really fun to look at, and it's one of my favorite globular clusters as well. Again, they never really disappoint. They're so bright and so amazing. I always like to ask guests when they come up here, when they look at a globular cluster, to think of different ways to describe it. So I've heard of things like, oh, a globular cluster looks kind of like a frozen firework, or maybe powdered sugar or glitter dusted on a black sheet of paper, or like raindrops on a spider web. So if you guys have any like cool ideas of how to explain a globular cluster, leave it in the chat because I would love to hear what you guys have to say. So we have another one coming up. The Cat's Eye Nebula. So let's go ahead and go to that. So I haven't looked at this one in a while, but it's a planetary nebula. So that'll be kind of a fun one to look at. And again, planetary nebulas are the end of life of stars that are around the size of the mass of our sun. So not massive enough to supernova, but they're just going to eventually shed their gas off over time. So it looks like the nebula is at the center of the screen. It's a pretty bright planetary nebula, and it's kind of in the shape of a cat's eye, hence its name. So this is a pretty small one. It is a nice blue nebula. We're starting to get a little bit more detail there. But yeah, it's a pretty nice bright nebula, and it's very circular. But yeah, this was kind of a fun one to look at. When we find it, it kind of looks like a blown up star, or kind of like a fuzzy star, but it's just all this gas that is going through right here too. Let's see, it looks like we have some more to look at. So someone asked if the Hercules constellation is up right now. It is up, it's in the west, but if you wanted to look at an image of it, this camera won't be able to do that because the constellation takes up so much space in the night sky, and we look at very, very small aspects of the night sky. So we're looking at very specific things such as a nebula or a globular cluster, which is tiny compared to an entire object. But if you had an object within the Hercules constellation that you'd like to look at, let us know and we can probably head there in a couple minutes. Let's see. Someone asked, how close are the stars in the last globular? Are they touching? No, so the stars themselves are not touching. Just when we take an image of them, it looks like they are touching just because we're not resolving all of these stars individually. So the stars definitely aren't touching. They're separated by at least like light years across from each other. They're separated by light years generally. They're just bound in this gravitational interaction. So that's kind of what is happening there. So let's just go ahead and head to M13, which is another globular cluster in Hercules. So you might have heard of the Great Hercules cluster, and that is M13. It is a really famous cluster to look at. And if you have a really, really dark skies that aren't polluted and it's a great night to look, you can actually sometimes see the Hercules cluster with your naked eye because it's super, super bright. So here we go. So here is M13. This one's a little bit different, so not quite as packed as the M15 that we just looked at. So we can start to resolve these stars a little bit more in the middle. So hopefully that can answer a little bit more of the question of, are these stars touching? So they're not. They're still separated by light years between each other. It's just that when we take an image, it looks kind of like they are touching, just because we aren't resolving each star individually. But these objects in general are pretty massive. There's a lot of space in between the stars still. So M13, again, an amazing cluster to look at. The stars are just so incredibly sparkly in this one. Not as densely packed as M15, which is kind of cool to see because we can start to see some of those stars on the outer edge a little bit more as well. So that one's kind of a fun one to look at. Let's keep going. Let's see. So close to the center of the globular, you can see a few stellar, or close to the center, globs can be as close to a few stellar radii. Yeah, so there's still quite a bit of space between them, but yeah, they definitely aren't touching. Okay, let's see. Before we head on, let's check to see if the Crescent Nebula is up, because that one's kind of a fun one to look at. And then we can head to the triple star, which someone asked for. So the Crescent Nebula is in the constellation Cygnus. It's about 5,000 light years away, and hopefully we can get this one. Sometimes it can be a little bit faint, but this one is pretty cool because it's formed by a really interesting type of star. So it's formed by the stellar wind of a Wolf-Rayet star, which I'll break that down for you. So a Wolf-Rayet star is a very advanced star in its life. It's very advanced in its life cycle, and it's losing mass really, really quickly. So basically, you can start to see kind of like that crescent shape, kind of like a crescent moon on the outskirts of this. Let's see. So again, kind of how this is created, this one's pretty cool. So it's created by the fast stellar wind of a Wolf-Rayet star, which is a very advanced star losing mass. And that type of gas is colliding with the gas that was shed earlier by the star becoming a red giant. So when a star becomes a red giant, it'll shed out some of its gas. And that gas is pretty slow moving. And then when this Wolf-Rayet star kind of started to form, it pushed out more gas, and that gas was faster moving. So the faster gas collided with the slower gas and created this like cocoon shape that we can see, or this crescent shape. So this one is pretty interesting to look at just because it is formed by a really interesting and very rare type of star. So Wolf-Rayet stars are extremely rare. If you guys want to know more about those types of stars, we've actually had a couple Meet an Astronomer live streams that talk about that with one of our astronomers, Phil Massey. So if you're interested in hearing more about that and some of the active research that Lowell Observatory is doing with these types of stars, go ahead and check those out. They'll be on the Lowell Observatory YouTube. So someone asked if we are able to separate M15 with an oxygen filter. So we're unable to put an oxygen filter on the type of camera that we're using for this telescope at the moment. But let's go ahead and head to that triple star that someone was asking for. So I think we're going to be looking at 16 Cygni, I believe. But nonetheless, we'll go to this triple star. There we go. Nice. So I think it's these three nice bright ones in the center. So we have a nice orange one that's pretty bright. Then we have two smaller blue ones coming out and across. This is a pretty cool one to look at. So kind of like a binary star system, this one's a relationship with three stars, which is pretty cool to look at too. So when we look at stars with this type of telescope, you might see those spikes coming off. That's not an actual physical that's not an actual physical aspect of the star. We call these diffraction spikes, which is basically just how the telescope is collecting light, and it creates that on the star. So that's not how the star actually looks. If you guys have any last requests, be sure to get them in soon. We can go back to M15 if anyone wants that. But while we're waiting for that, I have a couple announcements. So we have a couple live streams that will be coming up. The first one will be the Flagstaff Star Party, which will be a live stream on September 17th, starting at 7:30. So that one will be really fun to look at. Flagstaff as a city puts on this star party every year, and it's a lot of fun. But this year it's going to be more virtual just because of the COVID-19 that's happening. So that's something to look forward to. And we're also doing a live stream of Neptune at opposition, I believe. I don't know the exact date for that. Someone asked for the Whirlpool Galaxy. The Whirlpool is set right now, so it's too low on the horizon for us to be able to get, but we can do M33. So let's go ahead and go over to that one as one of our last objects. So this one's the Pinwheel Galaxy, sometimes called the Triangulum Galaxy as well. It's in the constellation Triangulum. And this one, this galaxy, along with Andromeda and the Milky Way, our own galaxy, is the three biggest members of the Local Group. Now, the Local Group is a group of galaxies that accompany us. So galaxies, like stars, cluster together. And so we have these galaxy clusters. And so the one that we're in is the Local Group. So the Triangulum is about 2.73 million light years away, and it's a spiral galaxy. So you can see with what we can do on this one, we can start to see some of that bright galactic center, and we can also start to see some of those spiral arms as well coming off from that center. So this is a face-on galaxy. We're looking at it kind of like straight down, which is cool to be able to see the expanse of the galaxy itself, which is pretty cool. So this is a good one to look at. It's still a little low in the horizon as well. So as time moves on, we'll be able to get better and better images of this one. Someone asked if we have a clear view of the moon. The moon is currently not risen for us right now. So we won't be able to get that tonight. But as kind of a fun last object to look at, we are going to head to Neptune. So most of the planets are up right now, which is pretty fun. But Neptune is the last planet in our solar system, and it's famous with its blue color. So we're going to go ahead and head to that as kind of our last object. So let's see. I haven't even seen Neptune through this yet, which it'll be fun to see with this. Neptune is interesting as well because I know most of you guys have heard of Jupiter's Great Red Spot, but Neptune also has kind of its own storm, which is called Neptune's Great Blue Spot, and it's a storm on Neptune's surface that is blue. It's a blue storm. Ah, there's little Neptune. Again, it's a super bright planet, so we're gonna play with the settings a little bit and see if we can resolve that a little better. But just looking at it, you can already start to see some of that nice blue color. But Neptune's also pretty far away from us, so we won't get as good of detail as with Saturn or Jupiter or some of these closer planets just because it's so far away. And also, Neptune is mostly just a big blue ball. So that's what we have right now. Neptune doesn't look too bad. Again, you can start to see that nice blue color. It's always fun to look at planets, I think. So there we go. Yeah. If you guys have any last questions, feel free to let us know and we can answer them. But again, I always like to hear what you guys think globular clusters look like. So if you have any suggestions, I always like to know. Leave them in the chat. But if you can, there's a lot of new live streams coming up for Lowell Observatory. So if you're interested in keeping up with the interactive stargazing, after September 17th, after our live stream of the Flagstaff Star Party, we will be moving to Tuesdays, weather dependent. So instead of doing interactive stargazing on Thursdays, we'll be moving them to Tuesday nights. So just something to keep in mind if you're looking forward to more of these. But other than that, if there's no further questions, I hope you all had a nice night. Thanks so much for joining us, and hopefully we'll see you next time, along with some of our other live streams that we're doing. Lowell Observatory is still being super active with their online presence as we move through the COVID-19 pandemic. But thank you guys so much for joining. This has been really fun. So yeah, thank you guys. Have a nice evening.